Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. I want to prove to you something really interesting about System D. And since it involves what you can prove in this system, the result is going to propagate forward to any extension of D that we look at in the future or have already looked at, such as System T. However, before I do that, I need to both remind you of a definition, and then there's another definition which I'm not sure I've ever given you. So that's what this video is for. I'm going to give you the definition of a modal constant formula. But the first definition, the one I need to remind you of, or tell you of if you haven't watched video 191, that is the definition of the PL transform. So if you have seen the video, you may remember that the PL transform of a formula is just the result of erasing any of the modal operators in it. So that definition is easy, but we are going to use it, so remember it. The other definition is the definition of a modal constant formula. So a modal constant well-formed formula. Now, you might remember from a very long time ago, back when we were doing propositional logic, the definition of a propositional constant formula. Well, the modal definition is just that, extended to a modal language. So a modal constant formula is a well-formed formula that is built up from top, which you'll remember is just an arbitrary tautology, bottom, or an arbitrary contradiction, and the logical connectives, negation, conjunction, disjunction, and implication, and the modal operators. So box and diamond. So these formulas don't involve any atoms. So some examples, we could have possibly bottom, necessarily possibly top, or necessarily bottom, possibly, if necessarily top, then possibly top, and so on and so forth. And then if you want to see what the result of the PL transforms of these formulas are, we'll just go through and delete or cross out all of your modal operators. And so this one becomes bottom, this one becomes top or bottom, and this one becomes top implies top. So just a brief reminder of what that definition is. Now, using these two definitions, we'll be able to prove something very interesting about System D, and something that's fairly surprising. And I'll tell you why it's surprising, because it also might not immediately be obvious why it's surprising. But anyway, join me for the next video, because it's going to be a good one. Until then, take care. Cheers.